Hello. Today I am going to discuss about network crashing in project management. So, I think in the previous video I have already taught you about how to draw the network, what is PERT, what is CPM, what is critical path, what is critical duration. So all these things I'm not discussing in this video, and I take for granted that you all know what is crashing, what is PERT, what is CPM, what is the critical path, what is the critical duration, and what are the critical activities. So today crashing. Crashing means you can see that it is reducing the project duration by increasing the resources. Like in case of conventional network, you can see that at the end of the node we used to get the critical time or the duration by which the project will be completed. If we want to reduce the time of duration of completion of the project, then we have to use additional resources in the form of men, materials, and machines. So if we use additional resources means it will consume additional cost. So crashing, what happens that crashing, by means of crashing, we these are the main materials and equipments are our direct cost. So crashing increases, by crashing we increases our direct cost, but it reduces our indirect cost. Under indirect cost comes our supervision cost, our security personnel cost. So when the time of duration of completion of project is reduced, so time of in that means the supervisor, that means the security personnel salary is also reduced for those days. Then supervision cost is also reduced if you apply if you appoint them for week wise basis or day per day wise basis. So crashing reduces the indirect cost, whereas it increases the direct cost. So in such a we have to do the crashing that the total cost does not exceed the original normal cost, as well as the duration of the project of completion is also reduced. So this we can explain by means of an example. Before that I am drawing the crashing curve. You can see that our x-axis is the time. This is basically a direct cost curve, and here you can see that CC is the crashed cost and CN is our normal cost. So this y-axis is our cost and x-axis is our time, and this is the normal time Tn and this is the crash time TC. You can see that normal cost is less because we are not using any additional resources, but it takes more time to complete the project. And if we crash further, so the time of completion is reduced. You can see TC is less but increases the cost. So slow crashing slope is defined as crashing slope. I think it's a normal mathematics slope. It is equal to Cc minus Cn divided by Tn minus of Tc. This is our crashing slope, and it will be very much useful while solving the problem on crashing, and we can decide whether further crashing is good or bad. So here you can see that one problem is there. You can see there are different activities starting from activity 1 to activity 4 5, and this second column is our the normal time, and this is the normal cost. I think this for this the problem is just like a simple problem. And other two columns you can see this is the crash time in weeks and this is the crash cost in rupees. You can see that crash cost is always more than that of your normal cost for each activity. So, and in the question it is given that if the indirect cost per week is rupees 250, it is fixed. That means this indirect cost is rupees 250 is fixed for this problem. What you have to do? Find the optimal crashed project completion time. So now what we will do, first of all we will compute. You can see that this is the question given to us. Now first of all we will compute cost slope using this formula. Crashing slope is equal to Cc minus Cn by Tn minus of Tc. So for the first activity you can see 1 2 activity. For this activity 1 2 we can see that crash cost is our 900. So crashing slope is for activity 1 2. Let's say this is for activity 1 2. 1, 2, it is our 900. 900 minus 700. 900 minus 700 divided by, you can see normal time. Normal time, you can see normal time is 13 weeks. It is 13 minus normal time. Crash time is our 9 weeks. So if we solve, you can see that it is your 200 divided by 4. 200 divided by 4 is equal to 50. So this is how cost law 50. Likewise, we will compute for activity 1 3 1 4 2 5 3 2 3 4 and 4 5. Now what is the crash limit? Crash limit crash limit, let's say for activity 1 2, crash limit is always the difference between the normal time and the crash time. It is normal time minus crash time. It is equal to, for the first case, it is 13 minus 9, it is equal to 4. So this is how it is 4. Likewise, we will compute for all other activities. Now we will compute the total normal cost. If you add all these sums, you will get, it is 700 plus 400 plus 600 plus 800 plus 900 plus 1000 plus 1500. You will get 5000 rupees, 5900. It is the normal cost. Now the very first step that we will start is, first we will draw the network as usual process, and we will write down as iteration 1. Iteration 1, like a conventional network, we have drawn the network and we have computed the critical duration. We can see that the critical duration and the timing that we have put, you can see that this is the normal timing. Till now we have not used the crash timing. This is 13, 1, 2, you can see it is 13, and for 1, 3 it is 5. 1, 3 it is 5. For 1 4, for activity 1 4, 1 4 it is 1 4 it is 7. You can see that 1 4 it is 7. In the question also you can see that 1 4 it is 7. Then similarly for 2 5 12, 2 5 12, 3 2 it is 6. For 3 4 it is 3 4 it is 5. It is 5. And for 4 5 it is 9. So we have used the normal duration, and using that we have computed, and we have calculated the, we have total normal cost is equal to 5900. We have seen this is the total normal cost, and critical duration is our 25 weeks. Critical duration is 25 weeks. Now comes our critical path. Critical path, you can see that here you can get two paths having the equal ESTs and ESTs and LSTs. And so you can see that 125 is one option, 125, and another you can get is 1325. Okay, but you can add, but the total duration is 25 weeks. For 1 to 5, if you add the all timings, 13 plus 12, you're getting 25. Fine. And for 1325, let's say it is equal to your 5, 5 plus 6 plus 12. How much it is? 11. It is 23. So it is 23. So this option ruled out. So 1 to 5 is the only critical path. So we can, so this is the critical path 1 to 5. So we can give it like, so this is the critical path. This is a symbol we used to give for critical path. So what are the critical activities? Critical path is our critical path is 1 to 5, and critical activities are our 1 2 and 2 5. 1 2 and 2 5. Now from the table that we have computed for 1 2, for 1 2, what is the crash limit? Crash limit is 4. 1 2 crash limit is 4 and cost slope is 50. So this thing we will feed here, cost slope 50 and crash limit 4. Similarly for 2 5, we have found that crash limit is 1 and cost slope is 65. You can refer to this table. 2 5, it is 65 and 1. Okay, now our crashing rule says that you will crash crash those activities or those activities or crash that activity, rather you can say crash that activity activity of the of the critical path having the least cost curve or cost slope. So in here in this case you can see that this 50 is the least cost slope, and its crash limit is 4. As so we can crash maximum 1-2 activity by 4 weeks. We can see the normal duration of our 1-2 activity is 13. So as this is the beginning of iteration, till now we have not started doing crashing. So one of the way is to do the iteration by crashing by unit crashing method. Unit crashing method means if for it is maximum limit is 4 weeks for activity 1-2, we can crash one by one. First we will reduce by from 13, we can do for 12 unit, then 11 unit, then 10 unit, then up to 9 weeks we can do that. This is this by unitary method we can do that thing. But here as it is the beginning of the crashing process, till now we have not crashed. So at a time for this problem, remember that for this problem, I am at a time selecting 4 as crashing limit. For this problem, this is for every problem is different and specific. For this problem, even if you go for unit by unit crash limit, then also it will be okay, but it will lengthy your process. So for this problem, I am crashing crashing the duration of activity, crashing the duration of activity by 4 weeks directly. If somebody is crashing using the crash limit of 1 week, 1 week, it's also not wrong, but only it will increase the steps. So it depends upon you how you choose. So now in the second page, now I will draw the next network. So iteration 2, let me start down. I'll draw the network again. Every time we have to draw the network again. Everything remains same. Okay. For activity 1, 2, it was earlier you can see that it was 13 weeks. 13 weeks, I am directly compressing by 4 weeks, so it will be now 9 weeks. For here, I am taking 9 weeks. All other timing remains same. For 2, 5, you can see that 2, 5, 2, 5, it was 12. So all other, if keeping all other times same, 12. For 1, 3, it was 5. For it was 7, it was 5. It was 9. Then for 2, 3, for 2, 3, it was 6. 6. So now we have put all the normal time as well as the crashing time for activity 1, 2. Now again we have to prepare the EST, EFT, LFT, LST, all tables at each and every node. You see, crashing. If your concept is very clear, it won't be a troublesome problem for you. If you understand this problem thoroughly, then you can solve any problem on crashing. So likewise, I'm starting from node 0, 0. So likewise, it will be 11, 11, then again 11. How come it will be 11? From here you will get 5. 5 plus 6 11, though as 9 is less than that of 11, I'm putting 11. And then here you can see that here it will be 5 plus 5 10, not 7. Then 10 plus 9, it can be 19, as well as here 11 plus 12, it is 23, so I'm putting 23 here. So here 23 again. So here you will get 11. Then here you will get 5. Normal, nothing new in that. 14. Now this iteration 2 we have completed. I think then we have to determine the critical path. You can get again 1, 2, 3, 1, 2, 5 as option. It seems like that. And another option is 1, 3, 2, 5. So let me calculate the duration of 1 to 5. 12 plus 9, it is 21. It is 21 weeks. It is not 23. 21 weeks. So it is ruled out. And 1, 3, 2, 5, it is 5 plus 6, 11, 11 plus 12, 11 plus 12, it is 23. So this 23 weeks, so this is the only critical path. This is the critical path. So now I'll mark down. This is the critical path. You can see this is the critical path. So first of all, the critical path is critical path. Likewise, if you follow the step, there won't be any error. So it is 1, 3, 2, 5, and critical duration, it is 23 weeks. And now comes the total cost. Remember that total cost, total, let me erase this. Then total cost is always equal to previous cost plus, as I have told you, crashing increases the direct cost. So it is increase, not direct cost. It is increase in direct cost minus indirect decrease in indirect cost. In this way you can determine. So likewise, if you compute, your total previous cost was rupees 5900. If you see that thing, you can see previous cost was 5900 plus you have crashed activity 1 2, and you activity 1 2 you have crashed, its cost slope was 50, and we have crashed for 4 limit. So it's increase in direct cost will be 50 into 4. So it is this much. We have compressed by 4 weeks, so 50 into 4 minus, and it is given in the question that indirect cost, you can see indirect cost per week is rupees 250. Indirect cost is always fixed, so it is minus 250. So ultimately you will get rupees 5850. So this is the indirect cost. And what are the critical activities here? You can see that critical activity, crash limit, crash cost, critical activities are your 1 3, 3 2, and 2 5, and its crash limit are 1 2 1, and it is crash cost. If you see from the table, it is 60 115 and 65. Now we have to, as a rule, I've already told you that you have to crash or those activity or that activity which has the minimum cost, crash cost. You can see out of this crash cost, this is the minimum crash cost. That's why I'm putting star here. So we have to crash the activity 1 3 by 1 unit. Now everything remains same. You will follow the this network. You forget the first network. So in this network everything will remain same. Only we have to reduce the duration of activity 1 3 by 1 unit. For 1 3 in the previous network it was 5 units. Now it will be 4. All other remain same. It will be 9, it will be 12, it will be 6, it will be 5, it will be 9, it is 7. Only the change will be in activity 1 3. So now I'll start iteration 3. Iteration 3. Likewise 1. So here I put 9, 12. Here this is reduced by 1, that is 4. That's why I've kept in bracket. All others remain as usual. 6, 9, 5, 7, and here, okay, I'll make the boxes everywhere. Now we'll start filling. Here you can get 4 plus 6, 10. Then here 10 plus 12, it will be 12. And here you can get it is equal to 4. Here you will get 4 plus 5, it is 9. 9 plus 9, 18. 9 plus 9, it is 18. And here you will get here your 12 plus 9, it is equal to, it is not 12, it is 22. Likewise, so here 22. So here you will get 10. Here 4. And here you will get 13. Now you can see that from the previous problem your duration was 23 weeks. Now it has reduced by 22 weeks. So there is a reduction in iteration 3. There is a reduction in project completion time. Let's see the total cost. So critical path you can see that here 1325, because you can get 12 plus 9 in case of 1 to 5, it is not, it is only 21, so it is ruled out. So only option is your 1325 critical path. Critical duration, let's say I'm writing down CD, it is equal to 22 weeks. So duration of project completion time has reduced. Now we have to compute the cost. Cost and time are most important thing. Total cost, it is equal to the previous cost. What was the previous cost? Previous cost was 5850. 5850. It is 5850 plus increase in direct cost. We have compressed the activity 1 3. Activity 1 3 by 1 unit means 60 into 1, it is 60. It is increase in direct cost minus decrease in indirect cost. Indirect cost given in the question is rupees 250 fixed. So you will get RS is equal to 5660. So you can see that from the previous cost, this cost at iteration 3, it is reduced at time as well as cost. Time has also reduced by 1 week and cost has also reduced. So again there is a scope for crashing. So next we can go for further crashing. So critical activities. So critical activities. This is the crash limit, and here cost slope. So here you can, the critical activities are 1 3. See 1 3 we have, okay, I'm writing it down. 1 3, it is 1 3 1 3 3 2, and here it is equal to 2 5. 1 3, you can see that 1 3 for crash limit was 1 and 60, that we have already existed, so here it will be blank. Here it will be blank. For 3 2 it is 215 if you see the table, and for 2 5 it is 165. So least cost slope is 65, that's why we will now crash activity 25 by 1 unit in the next iteration. So crash activity 25 by 1 week. Now we will go for iteration 3. Iteration 4. Iteration 3 we have already done. Now iteration 4. Iteration 4. For iteration 4, if you do it, in iteration 4 everything remains same. Uh, Activity 2 5, what is the duration of activity 2 5? It is 12. We will reduce by 1 week, so it will be now only here it will be 11 weeks, 11, all other timing remaining same. As come we will draw the iteration 4 with regards to the network of iteration 3. So here 9, here I am giving 11. It was earlier 12. All other remaining same as regards to the iteration number 3, network of iteration 3, 9. So here 4 plus 6, here it will be 4. 4 plus 6 it is 10. 10 plus 11 it is 21, because it is 6 plus 11 16, so greater one is 21. And here it will be your 9. 4 plus 5 9, 7 is less, so if we return back 21, here it will be 10, here it will be our 4, and here it will be 12. So if regards to the critical path, if we consider 1 2 5, same thing, 11 plus 9 it is 20, so it is not a critical path. Critical path is your 1 3 3 2 and 2 5. So critical path is 1 3 1 3 2 5, and critical duration 21 weeks. So we can see that from previous week it was 22 weeks. So 22 weeks it has been reduced by 1 week. So it's true, we are going in the right track. Now that let's calculate the total cost in this step. Our neither the cost should increase, cost should be reduced, as well as the duration should be reduced. That means crashing is right. Now total cost, previous cost is 5660 in this step. Rupees 5660 plus increase in direct cost. For activity 25 we have crashed, it is 65 into 165 plus 65 minus 250. So it is equal to your rupees 5475. So if you can see that cost has also reduced and time has also reduced. So iteration 4 is okay. Now we can go for the next iteration. So likewise, if we do it, so next you can see that This has been done, and the critical activity remaining here, critical activity, critical activities are 3 to crash limit and cost slope. Cost slope is for, it is for 2, and here it is 1. It is equal to 115. So you can see that here all other activities of this network, that means for 1 3 we have already existed, 3 2 is left, 2 5 also we have already taken. So that's why we have considered only activity 3 2. Crashing, if you understand the concept, you can work out any kind of problem on crashing. So you can see that 1 3 already existed, 2 5 also now existed. Let me, if you have any doubt, so let me write down in here also. So it will be very much clear to you. Critical activity 1 3, 3 2 and 2 5. Here we have already crashed it, and here 2 5 also we have done previously, and there is no limit left. Only for here it is equal to 2, only one option, and maximum you can crash by 2 units. Okay, so see, you can see that till now we have done so many iterations. So we can crash maximum this activity 3 2 by 2 weeks. But I will crash this activity first by 1 week, because in crashing there is a rule that you can maximum crash the limit by the compression limit. This is the compression limit of 2 weeks. So better, or you can go by unit method. That means by 1 week or 1 day wise you can crash it. As I have already done the iteration four iterations I have already done. So I'm doing now. I will go for compressing this by 1 week. But in the beginning, if you remember, in iteration 2 I have compressed directly by 4 weeks of activity 1 2, because it was the beginning iteration I did it. Crashing is little bit trial and error method. Because in this problem I have found out that if I crash the limit crash this activity 3 2 by 2 weeks directly, there will be increase in cost, or there won't be any difference in the project completion time. So that's why I'm crashing. So it's always safer when you go for at least 1 or 2 or 3 iteration. You, after that you crash by unit time method. So that is always better. Remember this thing. After 2 or 3 iteration, you crash by unit method. That will be better. So now I will crash. I will do iteration 5. Iteration 5, and I will crash activity 3 2 by crash activity 3 2 by 1 week, though its limit is 2 weeks. Later on I'll see, then if we can further compress. All other timing remains same. It was all usual 9, 12, it was 7, it was 5, it was 9. For activity 1, 3, it was 4. You see, for activity 2, 3, for activity 2, 3, it was 6 weeks. Now it will be our 5. That's why I'm keeping this in bracket. Now if I compute the EST, EFT, LST, LFT at each and every node, Let's see what is the project completion time. Let's say it is 0 0. Here it is 4 plus 1 9. It is also 9. 11 plus 9 it is 20. So it is 20. Here it is our 4, and here it will be our 9. 5 plus 4 9 rather than 7. And here it will be, if we return back 20, this is 20. 20 minus 9 11. And here it is 20 minus 11 9. 9 minus 5 it is 4. So we got this network. Now you can see that in the previously your project completion time was 21 weeks. Now the project completion time is, for iteration it is 20 weeks. So it has reduced, project completion time has reduced. Now what about the critical path? We can see that here you can have, here we can have a critical path 1 2 2 5, 11 plus 9 20, and also 1 3 3 2 3 2 5. So 1 3, so it is so two critical paths we are getting it. So first we will write down critical paths 1 to 5. It is one of the critical path because total 9 plus 11 20, and another is 1 3 2 5, 1 3 2 1 3 3 2 2 5. 5 plus 4 9, 9 plus 11 20, 20 weeks. And critical duration is equal to 20 weeks. Now path is okay. Now we will compute the total cost. Let's say total cost, it should reduce. Total cost, it is equal to, previous cost is 5475 rupees. 5475 plus increase in direct cost. What was the cost slope? You can see 115 into 1 because we have compressed by 1 week only. Plus 115 plus 115 minus indirect cost, it is your 250. So it is equal to rupees 5340. So now if by reducing the duration of activity 2 3 by 1 unit, we found that it is also beneficial. The duration of project completion time is reduced by 1 week. Also the total cost is also reduced. So there is a further scope for crashing. We will do for iteration 6. Iteration 6. Iteration 6. For iteration 6, first we will prepare the table. So critical path, critical activity, crash limit, cost, slope. Critical activity is here 1 to 5. Activities are 1, 2 and 2, 5. And crash limit, you can see we have already crashed. There is no scope, so there is no use of this critical activity. And for 1, 3, 2, 5, your 1, 3, 3, 2 and 2, 5. So here you can see that for 3 2 it is 1, all other remaining, all other we have already crashed, so there is only one option. This is 115. If we have to only crash this activity 3 2 by further 1 week. So let's say draw the network now again. Then it is 2 5, 3 4, then it is here 4 to 5. And duration of all remaining same, it is 9, it is 4, it is 7, it is 5. it is 11, it is 9. Only for activity for 2, 3, I'm using 5 weeks. Earlier it was 6 weeks. Sorry, earlier it was 5 weeks, so I will now use it will be as 4 weeks. So it is 4 weeks. All other are remaining same. Okay. Now I will construct the network. I have constructed the network. Now I will calculate the ESTs, LST, EFT and LFT that each and every node. Let's say whether the project completion time is reduced or further reduced or not. Start with 0. It is 9, 9 plus 11. It is 9 plus 11, 20. 20. It is 4, 4, 8, 8. It is 4. It is 4. So here it is. So it is 20. Here it is your 9. 9. If you again go back by this way, 20. So it is your 9. 9 minus 4, 5. Here it will be 11. So you can see that here in by reducing further the duration of this activity to 3 by compressing by 1 week, there is no decrease in project completion time. It is 20 weeks now. Here also you can see it was 20 weeks. So there is no required for further iteration. Iteration 6 not required. So iteration 5 is the answer. So this is the answer, 20 weeks. Critical path is 1325 because we have already this we have already crashed. 1225 we have already crashed. So critical activity is your critical path is 1325. Critical duration is 20 weeks and answer is here, and total cost will be 5340. So result, this is the final result. So what is the result for this final problem? Critical path is 1325, critical duration is 20 weeks and total cost is 5340. We are not considering the iteration 6 because by using the iteration 6 also we are getting the same time, 20 weeks. So no need to go further. So this is the result, this is the end. I think all of you got it. So please do practice more and more problem, and so your practice, you can, if more and more you practice, your all concepts regarding the crashing will be cleared.